Hi, my name is Mike Dorn, and today I want to talk about the biological part of climate that hasn't been really discussed much since the 80s in Lovelock's Daisyland. Uh, the state of the science, as far as when life came, most textbooks talk in your biology classes will talk about the Miller-Urey experiments, and most skeptics of this discussion will point to the fact that life tends to have a handedness to it, and the Miller-Urey experiments never addressed the handedness problem. And that's because when Miller-Urey did these experiments, where they had the basic chemicals of life, and they put electric currents through the flask and came up with amino acids. The amino acids had both hands. They had, from a chemical standpoint, they were not distinct. But in life, the handedness exists. And so the experiments then didn't explain why the handedness came about. And handedness is very important because these amino acids, you can take, see the L there in front of the lysine, you can take vitamins and they're very helpful to your health, but if you were to take R-lysine for right-handed lysine, it's a poison. And so the right and the left hand amino acid tend to bind with themselves and then become chemically useless for life. So the question is, where did that come from? And it's my view that the bioelectrical explanation of life and climate perfectly describes how handedness could come about. And the idea is this, that if you're talking about doing a test to see what DNA a sample has, say you wanted to find out what my DNA was, the way that they do it in a lab is they take a sample, and then they take away the stuff that isn't DNA, chemically remove it, and chemically amplify it, and then they take the sample that's been amplified and they put it in a gel, and then they have an anode and a cathode that creates a static field, and then the DNA begins to move inside this gel by its, first of all, of course, its weight, or its mass, its charge, and its size, and its shape. Because if it's shaped one way, it's going to move through the gel in one way, and if it's shaped another way, it's going to move the other way. Well, that explains handedness, because that's shape. So and that's how you capture the handedness if you're doing trying to get a DNA sample, and it comes out that you have these bands in the gel that you can tell what the chemicals are that make up the DNA, the sample. And everybody's is different. Turns out that all life has a lot of this DNA, much of the DNA has, or RNA, has no practical use in the life form. And that sets up a number of questions. Well, what was it used for? And again, without looking at electrics, I don't think you can answer that question, but I think you can answer it with electrics. And it's this idea that if you have a droplet of water in a convection process, and there's a static field, how that DNA moves in between one end of it to the other depends upon the exact same things as electrophoresis. It'll move by the mass, the charge, the shape, and the size of the molecule. So it will then have, because it's replicated, and you have the side of a cloud that has this DNA in it, it will change the character in a calculative way of how static fields move, how ozone is moved, how a storm would organize, and how a storm would then feed back rain to where maybe some of the chemicals of life existed. And would do so in a calculative way. It's very much like a variable resistor then. And you have to keep in mind that land is about 1,000 to 5,000 times more resistive, and the oceans, salt water, conductive, and you have a ocean then where couplings occur, and then land where shorts, lightning is about 90% more likely to occur. And it's very much like if you made a simple model between a battery, which is the land, and a capacitor with a variable resistor, which is the ocean, and where storms form, and then you would get feedbacks. So that's the origin of life. In life, it became calculative and responsive to climate, because otherwise the Earth's magnetic field would go away, the atmosphere could get stripped away. Over time, I believe the oceans have become more saline and responsive to a more luminous sun. And these are all intelligent, design-like features that come from the calculative power initially from DNA and RNA. And this is also how CO2 is tied in, because CO2 in pure water is highly insulative. You add CO2 as a gas form and it becomes 4 to 10 times more conductive, and the more CO2 that's in the atmosphere, the more conductive the droplet is. And again, this will explain how quickly mirror images can form on a droplet responsive to a static field. Highly sensitive that, and then highly sensitive is the ionosphere, which then through pressure feedbacks will help organize particularly tropical storms.